Okay, so this just so happens to be the first method we're going to look at, the average pressure loss method. And one thing we need to account for are pressure losses due to devices, some backflow preventers, for example, water meters, any other devices that may be installed. Elevation, 1 psi will be lost for every 2.31 feet of elevation. And the metric equivalent we use is 10 kPa per meter of head for design purposes. So that's even at static conditions. Divide remaining pressure by the longest equivalent run. So we're going to look at the longest measured run of piping in the system and then add in an equivalent length to represent fitting losses. Take a look at that in a minute. So at the end, once we do our average pressure loss calculation, we have to have this remaining residual pressure available. What this is trying to account for here is the available pipe friction for the system. And if we can meet all these criteria, then we're going to be able to use the table A2631-2F in the appendix. So this table here is what we'll use to size the distribution system for the average pressure loss method. Just touching on the longest equivalent run again, the rule of thumb, or the rough rule, is that measured length is taken for the system, and then we add 50% of that measured length to sort of accommodate all the fittings that may be in the system. That may be too much, it may be too little. Worst cases are usually what should be entertained. Some streamlined copper fittings, for example, may not require that much additional length to be added to the measured length of the system. But then again, some insert fittings for some different types of PEX installations, for example, may require higher than 50% to be added to the measured length. So manufacturers may have some recommendations on that as well, but the rough rule is 50% is added to the measured length to accommodate whatever friction loss there would be to fittings and valves. So here is that table A26312F in the appendix. It has 4 velocity columns available. The 3 meter per second column on the left, for example, might be used for some plastic products like polypropylene, CPVC, etc. The 2.4 meter per second column here, of course, is used for cold water and copper systems. 1.5 meters per second is used for hot water and copper systems, up to 60 degrees Celsius or 140 Fahrenheit. And for copper systems that have water that may exceed 60 Celsius or 140 Fahrenheit, typically 1.2 meters per second is utilized. So again, based on manufacturer's literature, we would select the velocity that would be appropriate.